Exercise 18. We come to my favorite feature of C. Some of the most crazy hacking can be done with pointers to functions. So the plan in this is we're going to study pointers to functions. These are very useful, but you don't encounter them too often. It's almost like a lot of C programmers don't get that you can do this stuff. It's sort of strange because it's really handy. All right, so let's look at the code. The code for this is really simple. We have our typical die friend. That's not a big deal. This is the super magic. So I'm using typedef, which we haven't really covered too much, but this is going to create a new type. And what I'm saying is I want the pointer to a function. So this whole form triggers pointer to function. And I want it to be named compare callback. Okay, so this is super kind of weird, but what you want to do is read through the book because the book explains it a little bit better. Okay, so you want to go through exercise 18 in the book. Make sure, yep, you want to do exercise 18 in the book, and it goes through how I typically try to write them. So you'll see where I'm basically saying, make your function like normal, like you would normally define it. Okay, and then wrap it with a parentheses and a star. Okay, so here we go. So let's say I want to make this here, right? No, wait, bubble sort. This one. So I write an example function that I want to be doing, pointers to, function pointers to. Okay, I'm going to rewrite that one up ahead. So, okay, so that's the function style, the function signature I want pointers to. So first thing I do is I come in and I wrap it with this. With an asterisk. And I put a parentheses around here. Then I go to the beginning and I do typedef and I slap a semicolon at the end. Then once I have that wrapped, I rename it. And there we go. Oh, and it would help if I spelled typedef right. There we go. See? Exactly the same. That's the process. So let's say I have a function called char star say my name, char star name. Let's say I got that. Okay, so this will print out my name. I want to make that a function pointer. So that way I can have any kind of say. Maybe it will do it with auditory. Okay, so what do? I wrap it. Oh, sorry, that's wrong. This over here is your type. Remember that. It's the return value type of this function. So don't do what I just did. You don't do that. That's a different function pointer. That returns a single character. I want this, and then I put the star in there. So wrap it, put an asterisk in it, change the name to say callback. You can name this anything you want. And then put your typedef on. There you go. That's how you make a function pointer. It's a strange syntax. It's not like all the other typedef syntaxes. Okay, so what does a function pointer do? Now that I have this compare callback, function pointer basically allows me, and yeah, this is our analysis section, so it allows me to pass a function by name to another function, or even set it as a variable in a struct or anything, and then this function is now generic. The bubble sort doesn't care. All it's going to do is right here, calls that function pointer like it's a function, and that function pointer will run. Bubble sort now doesn't actually care how you implement the sorting mechanism. Incidentally, you should study this bubble sort. It's actually your first little algorithm. Okay, so then what I did is I made a few pointers, a few different functions. I can do sorted order, reversed order, strange order. This is just like a gobbledygook, doesn't mean anything. And then I've got something that tests it. So it goes through, creates some sorting, freeze it, right? So I'm going to pass the comparator to 2 and calls bubble sort, make sure that it worked. And then finally, the arg v is used as our sorting, so we'll just pass some numbers into it. And then I convert them to integers, and then all I do is call test sorting using each of my sorting functions. So let's make x18. Oh, we gotta have our usage 4, 7, 7, 8, 1, 2, 194. All right, so the first one is sorted order, second one is reversed order, and the last one is weird order. And there you go. So what is a function callback? It's a way for you to pass another function to a function or set it in a structure, so that way you don't have to know what the implementation of the function is, you just need to know this pointer, and then you just use it like a function after that. So here's cool breaking time. So I'm just going to copy this code in, and let's see where I need to put it. Let's put it at the end. And format this up. Move this over. Okay. Oh, and I need to... Oh, you know what? Let's make a function for this called dump. Void dump. Compare callback. All right. So I've made a little function called dump. And let's save, make sure we got this right. I'm going to need int I there. Remember, always set it to a default. There we go. Double check this. I have a void return type. Data is going to be my comp. And see where I'm doing this? That's right. Are you figuring out the evil I'm going to do? This is super evil. I love stuff like this. This is so much fun. All right, so I'm going to do dump sorted order. Let me do this. Printf. And then let's do reverse order. Yeah, that's good enough. Okay, so dump is basically going to cast the function pointer to an unsigned character pointer, then go through the first 25 bytes and print it out. It's literally converting the code, the binary code that the CPU processes to execute, the executable in RAM, into character data. Yes, this is where C gets freaky. Because you can point any pointer pretty much at anywhere that your system owns or your user owns, or whatever it lets you allow, you can actually treat code like it's data. This gets very, very strange. So let's see what happens when we do this. Make that and do what we did before. This is the first bytes of sorted. And see how it says the same first bytes of, like, first few bytes are the same, and then right about here, nope, it looks like it's the same. So for the first 25 bytes of these functions, they're nearly the same. Yes, so what we actually did, not breaking it, it's just something kind of cool, is we went through and we basically did this dump. So what can we do instead? Let's do something super freaky. Let's make destroy, and let's do the first 25 bytes. Let's do data I equals I. So what we're doing, you're thinking nobody does this, and I'm going to explain why this happens. This actually does totally happen. But what we're doing is we're using the data pointer to overwrite the code for whatever compare function we have, and then replace it with numbers. So let's do this. Basically, what we're going to do is when I do dump down here, I'm going to do, let's do this. And then I'm going to do destroy in between those. So you can see that I destroyed it. So you'll see what it did before, you'll see what it did after. All right, so let's do that. And then we have an explosion. Super weird, right? So now let's see if we can see what we can get away with in destroy. So let's say we're going to do just the first 2 bytes. Nope, you can't write to any of this, which is great. This is great. And I'll tell you why. You'll love this. You might be able to find an operating system that didn't do this, but it looks like, at least in this one instance, we get lucky. Normally what happens when you try to overwrite code, you actually just can do it. A lot of operating systems don't have protection of memory code, of executable code. It looks like this one particular write, even if we do a single one, let's do one code, even that causes a bus error. So this means that I assume this version of OS X has protection of executable code, and you can't just overwrite functions. The significance of this is one of the major hacks, or one of the major ways you exploit C code, is you find a pointer that's pointing somewhere random, and you find a way to move it to a function, or write new code you want. So either you overwrite the function with your own code that you want that's malicious, or you find a spot in RAM where you can write the code, and then you figure out a way to point a function pointer at that code. So that's how you do that. If you want, try to find other ways that you can try to muck with this. So that's the end of the lecture. Go through the extra credit in the book. We do the extra credit. There's no point for me to read them all out and talk about them. These ones are pretty straightforward. And I will see you at the next exercise.